So we're moving on to lesson 3, which is on page 303. Here's what happens with polynomials. There's two methods of division: long division, which we just finished, and synthetic division. Students finish long division, they're like, okay, I get this and I like this. When you get a question on a test and I ask you to divide, you get to choose your method, long division or synthetic division. 99% of you are actually not going to do long division when I show you synthetic division. It is way easier than long division. The reason, though, why we have to teach long division is for calculus students. So they need long division to calculate slant asymptotes in calculus. That's why we do that. But once you see this method, you have way less variables to contend with. It's much cleaner and students think easier. Most students will choose this, but again, you decide. Flip your page. We're going to look at class example number 1. And we will set this up. I want you to scratch out what they give you. I don't like that they start it because you need to know how to set this up. Your division bar for synthetic division is an upside down division bar. So it looks like this. There's going to be 2 rows that we're going to fill in here. And the first top row is the polynomial. However, it is only the coefficient of each term. So first of all, let's look at our polynomial. This is our p of x. We have to make sure, 1, it's in descending order of x cubed, x squared, x1, constant, and we've got zeros as placeholders in. Once we have that, we could set it up. It would be a 2, -3, -8, and 15. What you put in front of your upside down division bar is the root of the divisor. So this is my divisor here, which is x minus 1. In order to figure out the root of the divisor, you just set it equal to 0 and solve for x. The root of the divisor is 1. So 1 goes in front of your division bar, upside down division bar. Okay, now here's the pattern for synthetic division. You always drop that first number, which is a 2. You carry out multiplication. So 2 times 1 is 2, and that's going to go here. And synthetic division is addition. Long division, we were always subtracting. Synthetic division, we're going to add. So you're going to add -3 plus 2, which is -1. Okay, what do you do from here? You multiply. -1 times 1 is -1. Then you add. -8 plus -1 is -9. Then you multiply. -9 times 1 is -9. Then you add. 15 plus -9 is 6. You are at the end. You circle this. That is going to be your remainder. This is going to be your q of x. And how do you figure out what this 2, -1, 9 means? Here's how you would do it. If your polynomial function is a 3rd degree polynomial, your quotient will always be 1 degree less. So that means that this is going to be a 2nd degree. So this would be 2x squared minus 1x minus 9 is my constant. And you're done. So the division statement, p of x is equal to, so remember, this guy up here was the polynomial. How do you get that? It is the divisor, which is x minus 1, times your quotient, which was this, and you add your remainder. Because the remainder is not 0, is 1 a factor of the polynomial? No. According to the division algorithm, this remainder is not 0, therefore we will not have an x-intercept here of 1. Okay, let's do the exact same thing. Let's look at our polynomial. Make sure it's in descending order of x. Make sure there's zeros as placeholders. So 5, 4, 3. Oh, we're missing the 3. So I'm actually going to rewrite my p of x. So 5x to the 5 minus 6x to the 4. We're missing an x cubed, so that will be my 0 placeholder, plus 3x squared minus 2x plus 1. Upside down division bar. The first row is filled out with the coefficient of each of these terms. So 5, negative 6, 0, okay. The divisor is what we normally put in front. This time in synthetic division, it's the root of the divisor. So x plus 2, what would the root of this divisor be? Negative 2. That is the root of the divisor. Drop your first term and you multiply. 5 times negative 2 is negative 10. Then what do you do? Add. It's always adding for synthetic division. So negative 6 plus negative 10 is going to be negative 16. Then you multiply. Negative 16 times negative 2 is going to give you a positive. 16 times 2 is 32. Then you add. 0 plus 32 is 32. Then you multiply. 32 times negative 2 is negative 64. Then you add 3 plus negative 64 will give you negative 61. Then you multiply. Negative 61 times negative 2 is going to give me a positive number. 61 times 2 is 122. Then you add. Negative 2 plus 122 is 120. Then you multiply. 120 times negative 2 is going to give us a negative number. 120 times 2 is going to give us negative 240. And then you add. And it's going to be 1 plus negative 240, which is negative 239. I always box in that last term. That is my remainder. So this question for A, it actually says use synthetic division to find the quotient and the remainder. So I've got my remainder boxed in. It was negative 239. Let's write our quotient. So Q of x is equal to. Remember that this is my quotient, and if this is a 5th degree polynomial, your quotient is always 1 degree less. This is going to be a 4th degree quotient. So that's going to be 5x to the 4, right? And then minus 16x to the 3. Plus 32, x squared. This will be minus 61x. And then my constant is 120. Okay, so that's your quotient. So very fast or much faster, much less work. So there's actually less of a chance of making a mistake. And that's what you get. Now it says, find the value of the polynomial when x is replaced by negative 2. Okay, so what we're going to do is let's write down our original polynomial. So our original polynomial is p of x is equal to, it was 5x to the 5 minus 6x to the 4 plus 3x squared minus 2x plus 1. What they want us to do is they want us to find what this polynomial would be, what p of x would be, when I substitute in p of negative 2. So p of negative 2. So what does that mean? Every single time you have an x, replace that x with a -2. Make sure you're using your brackets properly. So 5 -2 to the power of 5 minus 6 -2 to the power of 4 plus 3 -2 squared minus 2 -2 plus 1. I would enter this as one string in your calculator and hit enter as your answer. Anybody have what it is? It is -239, which hopefully you notice that was the remainder when I divided it by a root of -2, right? So whatever root this is, if I put p of that root, whatever answer spits out is always going to be the remainder. So it says comment on your answers in A and B. So you'd say the remainder when dividing, just put your little division symbol, the remainder when dividing by x plus 2, and then in brackets put root is equal to -2 or root of -2, right? So root of -2. So the remainder when dividing by x plus 2 is going to be the exact same value. So is the exact value of p of -2. Just inputting that root into your polynomial, you're going to get the same answer whether you do synthetic division or whether you input into your polynomial the root. Let's look at this one. Okay, if x plus 3 is the divisor, we got to calculate all these missing letters, so it's like a little puzzle. What number am I going to put in front of my upside down division bar, Jacob? -3. The root of the divisor is -3. Let's see if everything makes sense. The first thing you always do is drop that first term, and then you multiply, right? So 2 times -3 is -6. Emily, what do I do from here? You add. So 2 plus -6 is going to give you -4. Donovan, what do I do with that -4? You multiply. It's always multiplied from here. So -4 times -3. 2 negatives gives you a positive, and that's going to give you a 12. We always put the 12 here, right? Or we always put the number that we get there. Now, here's where we're getting into the first thing we're going to have to calculate. You know that you add at this step, right? So let's write this out off to the side and see if we could figure out what m is. What we have is -m plus 12 is equal to 2m. Combine your m's, so add m to both sides, and you're going to have 12 is equal to 3m, and divide by 3, what is m equal to? Sorry, it is 4. Yeah. Now, we know what this now is. What would this be? It would be 8, because 2 times 4 is 8. So that is actually 8. And you guys, if you want to see, here's another thing you could check. You could take this out now. -m is really -4, right? So if I just did this, -4. -4 plus 12 is 8. What's the next step? I could figure out my n right now. What's n? Yeah, -24, because it's this times this. That number always goes here. So 8 times -3 is -24. So that is what n is equal to. n is equal to negative 24. Now they want p, but p is what we've always been doing. We add. So 16 plus negative 24 would give you what number? Negative 8. P is equal to negative 8. What is the remainder? Negative 8. If I typed into the polynomial, I don't even know what it is, but if I typed in p of negative 3, what number would I get? Negative 8. Is this divisor a factor? No. If I punch this into my calculator, the polynomial, it is not going to have an x-intercept at negative 3. Let's do one more like this, same type of thing. Last question. Okay, set it up. First, always, descending order of x, 0 as placeholder. Make sure you have a constant. If you have no constant, it's going to be plus 0 at the end. X to the 3, x to the 2, x to the 1, constant. I'm happy. Jaden A, what do you want in front of the upside down division bar? Negative 2. This is my divisor. The root is negative 2. There's one other piece of information I could fill in this chart. Daniel, what is it? Yeah, and where does the remainder always go? Right here. So I've got to put a 3 there. So if you sort of forget to read that, that's going to be crucial in figuring out this answer. Okay, drop your first term, whatever it is. It's a 2. Multiply. 2 times negative 2 is negative 4. Add. Be careful here. A lot of you want to put a 0, but negative 4 plus negative 4 is negative 8. Multiply. 2 negatives will give you a positive 16. This answer, I do not know right now, but it is a plus 16. Right? That's what that guy is. A plus 16. And then this I could figure out because it's this times this, right? This times this. So I'm going to just do it off to the side. Negative 2 times a plus 6 will give me negative 2a minus 12. Yes. Thank you. Sorry. It's like, where did I go wrong? And actually, what should it be? Sorry. Negative 2a minus what number? 32. Yeah. Minus 32. See if you can figure out what a is. So you know it is this plus this is equal to 3. So 3 plus this guy is equal to the remainder, which is 3. This is just going to be 3 minus 2a minus 32 is equal to 3. That's going to be negative 2a. 3 minus 32 is negative 29. That looks like an a, but it's a 9. Add 29 to both sides. And then divide by negative 2, and you get negative what number? Negative 16. To check if you were right, One of the things you could do is if we think a is negative 16, I could punch in negative 2 times negative 16 minus 32. So here's what I would do if I was wanting to check. Wait, this might be frozen. Yeah, you guys' mine's frozen, so you're going to have to type it in. On your calculators, tell me what you get when you type in negative 2 in a bracket negative 16 and then minus 32. What does that give you? 0? Good, thankfully. And then this number plus this number equals the remainder, which is 3. And that's your answer. A is equal to negative 16. So that is synthetic division. You choose what you like better. You could use either. Okay, your homework will be, so I want you to practice now for the next 15 minutes synthetic division. Circle number 1. Circle number 2 and write pick 2. Last semester I assigned B and D, but you could pick any 2, or you could do all 4 if you really want to be good at synthetic division, but you could pick 2. Do number 3. Number 4. Number 5. And 6. I just want to see if you wanted practice, because for sure it's going to be on the quiz and the exam, those like find the missing letters, 10 and 11 you could do as well. Because remember, when I give you your quiz, it's just going to be one of these guys that you've already done. So you could do 10 and 11, or you could have stopped at 6, but these are both really good practice.